All right, so over the next few days, we're going to be looking at section 6, and the majority of that time will be in word problems. But today's lesson will not be word problems. We'll just do some generic math with problems that are y equals. Could be any kind of function. And we'll take some derivatives and learn how to do the actual math for what's called related rates. So when we want to see how something changes over time, you end up with the derivative that has dy over dt or dx over dt in your problem. And you'll have values to plug in for that. Someone will give you a rate, for example, of how dx is changing over time, and you will calculate how dy changes over time. And in a lot of these problems, they use the same formula for like an A, B, C, D type situation, but they'll give you different numbers to plug in, but you'll use the same formula. So you take the derivative once, and then you calculate 4 different things for it. So we're going to look at the square root of x first, because we all know the derivative of that off the top of our head, I hope by now. And show how do you calculate this information given what they want you to work with. So in number 1, the formula is y equals the square root of x. So we know the derivative of that would be dy equals 1/2 with the square root of x on the bottom dx. Everybody agree with that? That's our, if we think of it like implicit, that's what we would have been doing in our last section. Well, now we're just going to put a dt under each one of these, and it becomes a related rate problem. So the derivative work really isn't that different. It's just don't forget to put the dt part. Now, in part A of this problem, x is going to be equal to 4, and dx over dt is going to be equal to 3, and we're going to find dy over dt. So all we have to do is plug in what they give us and find the other variable that they're asking for. So since we have the derivative here already, it's really easy to plug in the x because it goes inside the square root. It's really easy to multiply by dx over dt because it's a number, 3. And then you just evaluate that since all the variables on one side got filled in. And so 1/2 times the square root of 4 on the bottom, that's the square root of 4 is 2, times 2 is 4. So that's really 1/4. And times 3 on the top would make it 3/4. So the rate at which dy over dt is changing is 3/4. So what that means is as x changes by 3, y is not changing as fast. Does that make sense? Okay. Now let's look at another example when they give us something a little differently. Still going to be using this formula. So I'm going to copy it and take it with me. All right, so in part B, it says x equals 25 and dy over dt equals 2. Find dx over dt. So this time I'm looking for how is x changing when y changes by a whole 2 units. So we fill in our formula. Now dy over dt is on the left will be 2. We'll have 1 over 2 square roots of 25 by plugging in the x value, but we don't know dx over dt that is multiplied by that derivative. But we know what the square root of 25 is. What is that? Times that. So that means I've got 2 equals 1 over 10 times dx over dt. How do I get rid of that fraction? I don't know how to divide. Flip multiply. So when I realize I don't know how to divide, I just flip multiply. And that becomes 20 for dx over dt. Now, if you need to show multiplying that by both sides, feel free. You also could think of that 10 as divided by 10, so I'd multiply by 10 because the 1's not that important. So as x changes by 20, y is only changing by 2. So x is changing by a whole lot more than y is in this question. All right, let's look at the next part. I'll tell you what, I'm just going to erase so I can leave my formula each time. So on part C, x is equal to 15, dx over dt is equal to 4. So in this problem, they gave me everything about x. When they give you everything about x, it's usually evaluate your problem because all your x's are on the same side in this equation, but that is not always true. That's because this problem really is explicit. So 1 over 2 square roots of 15 times 4 for dx over dt. So we're evaluating this problem. So how do I do that? Anybody got any ideas? Anybody got any ideas? Okay, what do I need to do with it? Okay, I can rationalize the denominator. Anything else I can do? Okay, I'm going to write that down, and let's look at that. He said multiply it together. Well, what could I have done? I could get a common denominator, but it won't help. It'll just make your numbers bigger. I can do what? Yeah. And I usually do that before I multiply, but it's not absolutely necessary that you do that before you multiply. But I definitely would do that before I rationalize the denominator. Because if you go back to what we taught y'all in Math 3, I believe is when you learned this, it's reduce the outside, reduce the inside. If it's square rootable, take the square root. If it's not square rootable, does it need treeing? If it's not treeable, then you rationalize the denominator. So you want to make sure this is completely reduced before you put the square root of 15 over the square root of 15. And then the final answer comes out to be 2 square roots of 15 over 15. And you always should go back and look at the outside in case it reduces, because sometimes it will, but this one doesn't. So that is what I get for dy over dt. So x is changing by quite a bit, because it's changing by 4. I'd have to turn that to a decimal to see if that's more or less than x, because I don't know what that would be as a decimal. Does that make sense? If I was really wanting to rationalize out which one's changing more. All right, and then sometimes, that's interesting. I didn't write down the problem correctly, I don't believe, for this last one, because it looks funny. I'm just going to switch pages. It's just easier. All right, so in part D, x is equal to 4, but I believe this was supposed to say dy over dt is equal to the square root of 2 over 3. I don't believe I wrote this problem down right, because I thought I had 2 that you saw for dx over dt and 2 you saw for dy over dt. So if I put that in for dy over dt, then 1 over 2 square roots of 4 times dx over dt would be how I'd fill in my formula, correct? Everybody agree? All right. So I can simplify this fraction here next to dx over dt to what? 1/4? And again, how do I get rid of that 1/4? All right, multiply by 4. So that's going to be 4 square roots of 2 over 3 equals dx over dt. So pretty much with a lot of these questions, depending on what kind of math's in the original problem that you took the derivative of, you're either evaluating it, because I gave you everything on one side, or you're solving it. And now if you get a real implicit formula why x's and y's are on the same side, then you're going to have to do more solving. But if your y is a y equal to type problem, then it's not quite as much solving. It's more evaluating and a little solving. All right. And I numbered these problems kind of strangely, and I do this quite often. I try to pick odd problems out of the book to go by so that when you have even problems to do, if you need to go back and look at an odd one, it's one close by your number. So this next one is number 3. And I would sequentially do them, but then that wouldn't be as helpful to you. All right, so this problem is x times y equals 4 is the original problem. And first we're going to do the derivative work and get our derivative all simplified out. Then we're going to get values to plug in. What kind of derivative work do I need to do this time? Okay, it's a product rule, right? And it's implicit. So not only have I got to deal with product, but every time I put dx, I got to remember to put that dx and dy on those terms as I go. So it's write down the first. What's the derivative of the second? All right, 1 dy, we're going to put a dt under it. Plus, write down the second. What's the derivative of the first? All right, so we'll put it over dt, and that's equal to 0. Now, at this point, I have two choices. I can clean this formula up now, or I can wait and clean it up later when I have numbers plugged in. Now, if I wanted to solve it for dy over dt, would that be extremely hard for this question? You're right, it's not, because I just need to move a couple of things and they'll be done, right? So sometimes it might be to your advantage to do that, to solve it for dy over dt. Sometimes that might not be an advantage. You have to kind of decide, do I want to plug the numbers in and solve because it's easier to do it with numbers? Or do I want to clean the formula up a little bit because that might help me in the later part? Because I could move this over and divide by x, and dy over dt would be by itself. And then every time I want to find dy over dt, it would be straight plug-in. But some people would say, no, I'd rather put the numbers in because I could see it better with numbers. So that may vary a little bit with y'all. So we could look at one way if you wanted to, and we could look at another one the other way if you want to. But I think for this particular question, if I solved my formula first by taking that over to the other side by subtraction, then the opposite of multiplying by x would be dividing by x, right? So my formula would be dy over dt equals negative y over x times dx over dt. And that might be easier to plug numbers in because if I want dy over dt, I just plug those numbers in and work it out. If I want dx over dt, then I know I'm going to flip multiply. Does that make sense? Now that one might be true with every implicit formula. Not every implicit formula do you want to try to solve it. This one was not complicated to solve for dy over dt. If you think it looks complicated, I would leave it the way it is after I've done the derivative and just start plugging numbers in. Now, let's look at some numbers. So on part A, we have x equals 8 and dx over dt equals 10. So let's look at what do I have to plug in. So I don't know dy over dt because that's what I'm looking for. Everybody agree? I got a 8 to put down here for my x. Everybody agree with that? I have a 10 to put in over here for my dx over dt. What do I not have? I don't have y. In implicit formulas, they usually don't give you one of the numbers you need, but you can take the original problem, xy equals 4, plug in the value they gave you for either x or y, whichever one they give you, and solve for the other one. So what would y have to be in order to multiply it by 8 for it to go down to 4? That's right. And I could just divide by 8 to figure that out if I didn't know. But that one's just an obvious one. So once I get that, that's even worse. because now I've got negative a half on top for negative y to divide by 8. Oh well, we'll figure it out. You could. You could half the 10 over there. That is one way you could do it. Another thing you could do is you could move the 8 over under the 10, and then it would be negative 1/2 times 10 over 8. That also would work, because it doesn't matter which fraction this is under. So you have some choices. But it is real easy to multiply the tops together if you put a 1 under this. So that would be a really good strategy. Negative a half times 10 is negative 5 over 8. And then you're done. But I could have said negative 1/2 times 10 over 8, moved the 8 under the other one, and I still would have get the same answer. But it would have took a little bit more math. All right, let's look at a different perspective this time. What if they give me dy this time and ask me to find dx? So in B, x is equal to 1. Well, don't mean to put an equal mark there. And dy over dt is equal to 6. And they're asking me to find dx over dt. So again, I don't have y. Now sometimes they'll give you y and not give you x in this particular type of problem. So if xy is equal to 4 and x is 1, y has to be 4 then. Everybody agree? So we've got to solve an implicit formula for that variable that we don't have and then plug it in. So 6 is equal to negative 4 over 1, because it's negative y over x, times dx over dt. So pretty much, that's just negative 4 in front of that, right? So I'm going to divide by negative 4, or flip and multiply if you want to think of it as flip and multiply. So that's just going to be negative 3 over 2. Now let's talk about what these two answers mean. So the rate of y is changing by a fairly large amount, 6. And my dx over dt is telling me that this is decreasing by 1.5, while this is increasing by 6. Does that make sense? So my x's are getting smaller while my y's are getting bigger. So it's probably got a negative slope in there somewhere. All right, let's see here. Okay, on part C, I'd like to go back up here and show you an example of what if I had not solved this. So I'm going to copy that to the next page, because I want you to see that you don't have to do that, and you can decide sometimes not to do that ever if you wanted to. It is not required that you solve that for dy over dx. So a lot of times your formulas are too hard to do that. And so I thought it wouldn't be a bad thing to just show, what if I had not done that, what would happen? So in part C, x is equal to 3, dy over dt is equal to negative 2, and we're trying to find, again, dx over dt. And what do I still not have again? Right, I don't have y. So if x is 3 and x times y equals 4, then it's obviously not going to be a whole number. Correct. 4/3. So if y is 4/3 and x is 3 and the dy over dt is negative 2, by using this formula not solved for dy over dt, it doesn't make the problem any harder or any shorter, really. It just basically gives you a different perspective. So I have 3 times dy over dt, which is negative 2, plus 4/3 for y times dx over dt equals 0. So it looks like I can times that first part together and get -6. Would everybody agree with that? And then what should I do? Right, add the 6 to the other side because you're wanting to get your constant away. So 4/3 dx over dt is equal to 6. And then what do? Yeah, flip multiply by 3/4. So dx over dt is whatever I get from multiplying 6 times 3 and dividing by 4, or reduce it first. Because it doesn't matter if you multiply first or reduce first. See, I like to reduce first. Because 2 goes into this and 2 goes into that. And then when I multiply, I'm done. 9/2. So as my y is decreasing by 2, my x is increasing by 4.5. Does that make sense? I don't have a part D for that one. So now, going to change our perspective slightly and give a little bit more information. It's not really a word problem, but it kind of seems like more like a word problem. And this relates to question number 5 in the book. It says a point is moving I'm getting tangled up in that cord along a graph of f of x such that dx over dt is 2 centimeters a second. Find dy over dt. Now, that's the generic information they give you, and then they give you some other information to work with for part A, part B, or part C. But that's the generic information. So, they also might have thrown the formula in there somewhere. So let me write the formula. For y equals x squared plus 1. So we know that's a parabola that starts off on the y-axis at 1. So the key here is I could look at every place along the curve of the graph and talk about how the x is changing in centimeters per second and find our dy over dt, which also would be in centimeters per second because the units have to be the same. So for part A, it says find x equals, whoop, too many equal marks, x equals -1. So I need my derivative worked out so that I can plug in what I know so far. So what is dy over dt going to be equal to for this question? Correct. 2x dx over dt. Because we know when we take the derivative of y, we have to put a dy, and we know when we take the derivative of x, we have to put dx based on implicit. We're just adding the part about dt to it so we can find a rate. Now we can plug in what we know. dy over dt, whoa, that's a bad y, is equal to, it says 2x, so we're going to multiply 2 times the x value of -1 times the 2 centimeters per second. And I suggest writing your units in because when you do word problems, in order to figure out what the unit on the final answer is, sometimes it is helpful to write your units in the question so you can multiply all your units together or divide some of them out to get your final units. For this, we would have known it would have been that anyway, but for word problems, it might not be. They don't stay the same always. So what do I get? Okay. And what that means is it's decreasing at 4 centimeters every second. So we could take that negative now, and we can talk about that and say decreases. Well, it'd help if I could write today. Decreases 4 centimeters a second. So we can interpret what that negative means. Now, sometimes they'll give you all kinds of values, okay?
Teachers and students, please pardon this announcement. The following students are ready to take the CP test and should report to the Media Center at this time and bring their belongings with them. Austin Berg, Cheyenne Wheeler, Kenneth Toombs, Alex Rideout, Ronnie Pennington, Kobe Clark, Harley Jessup, Nicholas Dilk, Bailey Durham, Casey Bolden, Brianna Schaefer, Lauren Collins, Braden Bullins, Jacob McGee, Brandy Bolins, Jackson Bowles, Addie Bryant, Lacey Frazier, Stephen Paddock, Andy Sis, Leighton Helms, Cheyenne Lundgren, Brittany Lajeunesse, Kristen Sands, Jacob Bullins, Sarah Russell, Nathan Rose, Laura Wood, Brenda Chavez, Autumn Knight, Meredith Racy, and Heaven Ratcliffe Jones.
I hate it when they make an announcement and I don't have the little thing up on my board so I can pause the video, because then they have all the announcement in my video. But oh well. That's life. Okay, I've drawn the graph, just a generic giraffe. Oh my, I need some sleep. Talk all kinds of crazy words today. Just to talk about these two places where -4 and +4 would be. Now, if you think about it, your values of x are coming across and going up to this value on each side, so they're across from each other, right? So do you think there's some relationship to what the answer to the question would be for the rate for dy over dt? Okay. What do you think's the difference in the relationship? Well, what's happening to your rate over here? And what's happening to your rate over here? Okay, so if we do the math, we should see that, right? Okay. Well, what I'd like you to do is take the formula that we just made up here, the dy over dt formula, plug in the information that you've got, do it with 4 and do it with -4, just like I did -1, and I want you to compare those two and see if they make sense to you on what they come out to be. And I'm going to pause the video while y'all do that. So if you do dy over dt equals 2 times 4 times 2 centimeters per second, because all we're doing is taking the formula we had up here and just changing the x value, what did you get?
16.
All right, and then that's that's positive. That's centimeters per second. But when I put a -4 in, I get. So when you have something that's fairly symmetrical like this, and you do a point on each side, all you should expect to be different if the value you're plugging in for x is the same on both of them except for the negative, is that one's increasing and one's decreasing, right? So this first one here is increasing 16 meters per second, while the second one is decreasing 16 meters per second. And so that can be, something that's important to know, because you've got similar rates just at different directions. And that's what velocity is all about. Velocity is all about speed and direction. So these are both going the same speed, 16 centimeters per second. They're just not going in the same direction. Does that make sense? All right. Now, we'll do one more with the same kind of direction that I did on number 5 about a point moving, but the formula is going to change. And but we're still going to use the same rate. So in number 7, we're using the same directions with a different formula. And the formula this time is going to be y equals tangent of x, because I thought it would be good to look at a trig example. So the derivative of dy over dt is going to be equal to what? Secant squared. Dx over dt. So in part A, they ask us to figure out x equals -pi over 4. Now, what usually causes trouble in anything in calculus is remembering your entire unit circle from memory, because there is no unit circle on their test. So you have to know the whole thing. So we're going to put in dy over dt equals secant of negative pi over 4. Whatever we get for that, we're going to square it. And we're going to multiply it by 2 centimeters per second, because we're using the directions for number 5 to do number 7 with just a different formula. Does that make sense? On why my rate's still that, because that was in the directions. Now, negative pi over 4, remember, is a quadrant 4 angle. And in the quadrant 4, the second one's negative and the first one's positive. Everybody agree? You go across to the right and down. And secant's the reciprocal of cosine, so at least they let us use the value where both of them are the same, so you wouldn't actually get that wrong. Because every time you do force, you know they're square root 2 over 2. You just got to remember which one's positive and which one's negative. But secant's the reciprocal of what? Cosine. So we're going to do this one. So we're going to flip it and plug it in our formula. Now, notice that when you flip it, that puts the radical on the bottom. That does not mean I want to rationalize the denominator, because I'm getting ready to square it. Yeah, this is going to square out anyway. So be careful about jumping to the conclusion of rationalizing the denominator really quickly, because in this case, this is already going to be 4 over 2, because you're going to square the top and square the bottom. And then when you multiply it by 2 centimeters per second, the 2's cancel, and you get 4 centimeters per second. So the x is changing by 2 centimeters, while the y is doing twice as much. At that location. Now, they could ask us to do a different value, so we're going to look at one more example, and same formula, same derivative, just changing the x value so we can practice with another trig value. So in part B, they said x was equal to 2 pi over 3. And they still want me to find dy over dt. So first I have to know the secant at that location. I need to know the secant at 2 pi over 3, which we can figure out based on our patterning. And then we're going to multiply that by 2 centimeters per second after we square it. Now remember, 2 pi over 3 is in quadrant 2. It's the first line. And in that quadrant, the first one is negative and the second one is positive. To figure out what that one is, I need to know what 1/3 is so I can flip it over there. So if you remember that this is 1, 0, then this one has a 1 on top, a square root of 2 on top, the square root of 3 on top for the signs. Remember how we did that? We patterned it backwards. If this is 0, the second number is 1, square root of 2, square root of 3. So this one over here is going to have the square root of 3 there, and it's going to be negative 1/2 at the top on the front side. So you got to just pattern it off till you get to the hole that you can flip over there. And then make sure you put the negatives and positives based on the quadrant you're in. So it's negative 1/2 for the cosine, so it's negative 2 for the secant. So if I square that and multiply it by 2, then this one is changing by, yeah, make sure you square out the negative, because negative squared is a positive. And just multiply it all together. And it's positive 8 centimeters per second. So this one's changing by a whole lot faster rate than the previous one. Well, if you think about it, tangents are a graph that looks like this, right? One arm's up, one arm's down. The higher you go up that arm, the steeper it gets. So that would make sense why it would be so much more than negative pi over 4, because negative pi over 4 is not that far away from 0. But this is further away from 0, so it would have a much larger value for the rate. All right, so the assignment for this is fairly short, because I'm just focusing on using your textbook to let you practice just some calculations with derivatives of this. Then we'll get into word problems, and I've made worksheets for that because I don't like the way the book does it. They kind of just randomly throw in everything under the sun and don't really, well, my worksheets may be that way too, but some of their word problems are not very well worded. So for 2.6, your assignment's going to be on page 146, and you're going to do 2 through 10 even. And the first two questions I did in the notes are like the first two questions for 2 and 4. 6 and 8 are very similar to what I just did for 5 and 7. And number 10 is just asking you to describe some information about a graph. So based on what we've discussed about looking at a graph, you could probably tell me if it's increasing or decreasing what it's asking without me going over one of those. But if not, you can let me know. But it's just asking you to describe the graph. You don't really do any calculations for that. So I think that'll be okay. So that's what your assignment is. Now you also have your word problems that you are working on that need to be turned in today. So if you don't have that done, you might want to finish that first. If you do have it done, it goes in the bottom basket.